Now that we have the skills to work with vectors in 2 dimensions, we can apply vector addition to graphically determine the resultant vector, which represents the total force. Consider an example of force involving 2 ice skaters pushing a third as seen in the figure. Part A shows an overhead view of 2 ice skaters pushing on a third. Forces are vectors and add like vectors, so the total force on the third skater is in the direction shown. In Part B, we see a free body diagram representing the forces acting on the third skater. In problems where variables such as force are already known, the forces can be represented by making the length of the vectors proportional to the magnitudes of the forces. For this, you need to create a scale. For example, each centimeters of vector length could represent 50 newtons of force. Once you have the initial vectors drawn to scale, you can then use the head-to-tail method to draw the resultant vector. The length of the resultant can then be measured and converted back to the original units using the scale you created. You can tell by looking at the vectors in the free body diagram in the figure that the 2 skaters are pushing on the third skater with equal magnitude forces, since the length of their force vectors are the same. Note, however, that the forces are not equal because they act in different directions. If, for example, each force had a magnitude of 400 newtons, then we would find the magnitude of the total external force acting on the third skater by finding the magnitude of the resultant vector. Since the forces act at a right angle to one another, we can use the Pythagorean theorem. For a triangle with sides A, B, and C, the Pythagorean theorem tells us that a squared plus b squared is equal to c squared. So c is equal to the square root of a squared plus b squared. Applying this theorem to the triangle made by force 1, force 2, and the total force, we get F total squared is equal to the square root of F1 squared plus F2 squared. Or total force is equal to the square root of 400 newtons squared plus 400 newtons squared is equal to 566 newtons. Note that if the vectors were not at a right triangle to each other, or 90 degrees to one another, we would not be able to use the Pythagorean theorem to find the magnitude of the resultant force. Another scenario where adding 2-dimensional vectors is necessary is for velocity, where the direction may not be purely east-west or north-south, but some combination of these 2 directions. In the next section, we cover how to solve this type of problem analytically. For now, let's consider the problem graphically.